Welcome back, fellow space enthusiasts. Today, we're diving into the captivating world of our celestial neighbor, the Moon. This mysterious and enchanting orb has fascinated humans for centuries, sparking countless myths, legends, and scientific inquiries. So sit back, relax, and let's embark on this cosmic journey together. The Moon, our closest celestial body, has been a source of wonder and inspiration since ancient times. As the only natural satellite of Earth, it plays a crucial role in our planet's ecosystem and has a profound impact on life as we know it. With its barren, cratered surface and serene glow in the night sky, the Moon has captivated generations of dreamers and scientists alike. The Moon is Earth's most constant companion and the easiest celestial object to find in the night sky. The rhythm of the phases of the Moon has guided humanity for millennia. For instance, calendar months are roughly equal to the time it takes to go from one full moon to the next. But the Moon's orbit and phases can seem mysterious. For example, the Moon always shows us the same face, but it's always changing size as how much of it we see depends on the Moon's position in relation to Earth and the Sun. While it's a satellite of Earth, the Moon, with a diameter of about 2,159 miles, 3,475 kilometers, is bigger than Pluto. The Moon is a bit more than 1/4, 27%, the size of Earth, a much larger ratio, 1:4, than any other moons to their planets. This means the Moon has a great effect on our planet and may even be a major factor in making life on Earth possible. There are various theories about how the Moon was created, but recent evidence indicates it formed when a huge collision tore off a chunk of the primitive molten Earth, sending the raw ingredients for the Moon into orbit. Scientists have suggested the impacting object was likely about 10% the mass of Earth and about the size of Mars. Because Earth and the Moon are so similar in composition, researchers have concluded that the impact must have occurred about 95 million years after the formation of the solar system, give or take 32 million years. The solar system is roughly 4.6 billion years old. In 2015, new research gave further weight to this theory, using simulations of planetary orbits in the early solar system as well as newly uncovered differences in the abundance of the element tungsten, 182, detected in the Earth and the Moon. While this theory, most commonly known as the large impact theory, is the dominant theory in the scientific community, there are several other ideas for the Moon's formation. These include the concept that the Earth captured the Moon, that the Moon fissioned out of the Earth, or even that Earth may even have stolen the Moon from Venus. The Moon very likely has a very small core, just 1% to 2% of the Moon's mass and roughly 420 miles, 680 kilometers, wide. It likely consists mostly of iron, but may also contain large amounts of sulfur and other elements. The Moon's rocky mantle is about 825 miles, 1,330 kilometers, thick and made up of dense rocks rich in iron and magnesium. Magma in the mantle made its way to the surface in the past and erupted volcanically for more than 1 billion years, from at least 4 billion years ago to fewer than 3 billion years ago. The crust that includes the lunar surface averages some 42 miles, 70 kilometers, deep. The outermost part of the crust is broken and jumbled due to all the large impacts the Moon has endured, with the shattered zone giving way to intact material below a depth of about 6 miles, 9.6 kilometers. Like our solar system's 4 innermost planets, the Moon is rock. It's pockmarked with craters created by asteroid impacts millions of years ago, and because there is no weather, the craters have not eroded. The average composition of the lunar surface by weight is roughly 43% oxygen, 20% silicon, 19% magnesium, 10% iron, 3% calcium, 3% aluminum, 0.42% chromium, 0.18% titanium, and 0.12% manganese. Orbiting spacecraft have found traces of water on the lunar surface that may have originated from deep underground. They have also located hundreds of pits that could one day house explorers living on the Moon long term. Ongoing observations from the Lunar Reconnaissance Orbiter, LRO, have shown that water is more abundant on slopes facing the lunar south pole, although scientists do caution that the water quantity is comparable to an extremely dry desert. Meanwhile, a 2017 study suggested the Moon's interior could be abundant in water too. The Moon has only a very thin atmosphere, so a layer of dust or a footprint can sit undisturbed for centuries. And without much of an atmosphere, heat is not held near the surface, so temperatures vary wildly. Daytime temperatures on the sunny side of the Moon reach 273 -3 degrees Fahrenheit, 134 Celsius. On the night side, it gets as cold as -243 F, -153 C. The moon's gravity pulls at the Earth, causing predictable rises and falls in sea levels known as tides. To a much smaller extent, tides also occur in lakes, the atmosphere, and within Earth's crust. High tides refer to water bulging up from Earth's surface, and low tides when water levels drop. High tide occurs on the side of the Earth nearest the moon due to gravity, and on the side farthest from the moon due to the inertia of water. Low tides occur between these two humps. The pull of the moon is also slowing the Earth's rotation, an effect known as tidal braking, which increases the length of our day by 2.3 milliseconds per century. The energy that Earth loses is picked up by the moon, increasing its distance from the Earth, which means the moon gets farther away by 1.5 inches, 3.8 centimeters, annually. The moon's gravitational pull may have been key to making Earth a livable planet by moderating the degree of wobble in Earth's axial tilt, which led to a relatively stable climate over billions of years in which life could flourish. The moon doesn't escape from this interplay unscathed. A new study suggests that Earth's gravity stretched the moon into its oddly distorted shape early in its lifetime. During eclipses, the moon, Earth, and sun are in a straight line, or nearly so. A lunar eclipse takes place when Earth is directly between the sun and the moon, casting Earth's shadow onto the moon's face. A lunar eclipse can occur only during a full moon. During a full lunar eclipse, because the moon is in shadow, it can appear blood red in the night sky. A solar eclipse occurs when the moon passes between the sun and the Earth, casting the moon's shadow onto Earth. A solar eclipse can occur only during a new moon. Depending on the degree to which the moon blocks the sun is seen from a particular location on Earth, a solar eclipse can be total, annular, or partial. Total solar eclipses are rare in a given location because the shadow of the moon is so small on the Earth's surface. The Earth's axis of rotation is tilted about 23.5 degrees in relation to the ecliptic plane, an imaginary disk through Earth's orbit around the sun. This means the northern and southern hemispheres point somewhat toward or away from the sun depending on the time of year, varying the amount of solar radiation they receive and causing the seasons. But the moon's axis is tilted by only about 1.5 degrees, so the moon doesn't experience noticeable seasons. This means that some areas are always lit by sunlight, and other places are perpetually draped in shadow. Some ancient communities believed the moon was a bowl of fire, while others thought it was a mirror that reflected Earth's lands and seas. But ancient Greek philosophers knew the moon was a sphere orbiting the Earth whose moonlight reflected sunlight. The ancient Greeks also believed the dark areas of the moon were seas while the bright regions were land, which influenced the current names for those places: Maria and Terrae, Latin for seas and lands, respectively. The Renaissance astronomer Galileo Galilei was the first to use a telescope to make scientific observations of the moon, describing in 1609 a rough, mountainous surface that was quite different from the popular beliefs of his day that the moon was smooth. In 1959, the Soviet Union sent the first spacecraft to impact the moon's surface and returned the first photographs of its far side. This spurred a series of Cold War-era uncrewed missions launched by both the Soviet Union and the United States to observe the moon's surface. Many of these early moon probes were failures, or only partially successful. However, over time, these missions began to return information about the moon's surface and geological history. The United States launched a series of missions dubbed Pioneer, Ranger, and Surveyor, while the Soviet Union sent probes under the names Luna and Zond. The United States sent astronauts to the moon's orbit and surface in the 1960s and 1970s. The first crewed mission to the moon was in 1968, when the Apollo 8 astronauts orbited it. In 1969, Apollo 11 landed the first astronauts on the moon, followed by 5 more successful surface missions and one, Apollo 13, that didn't make to the moon but returned home safely. The moon remains the only extraterrestrial body that humans have ever visited. The Apollo program's efforts returned 842 pounds, 382 kilograms of rocks and soil to Earth for study. Scientists continue to study the rocks and have made new discoveries as technology has improved. For example, in 2013, water was found in samples from Apollo 15 15, 16, and 17. An interesting find given that previous analyses showed these rocks were quite dry. The Soviet Union remained active in robotic lunar exploration through the 1960s and 1970s. The first robotic lunar sample return mission took place with Luna 16 in September 1970 after multiple failed attempts with other missions. The Soviets also deployed the first robotic lunar rover, called Lunokhod 1, just 2 months later. Lunokhod 2, which deployed in 1973, set an off-world distance driving record for more than 40 years, until NASA's long-running but now-defunct Mars Opportunity rover mission surpassed it in 2014 after several years of driving. After NASA's Apollo program ended, and following an interlude of more than a decade, lunar exploration by U.S. spacecraft resumed in the 1990s. Since then, a host of other government space agencies have also joined the moon rush, including Japan, the European Space Agency, China, India, and Israel. China is the only one of those countries to successfully operate on the surface of the moon. Landers sent by the latter two nations crash-landed. Among other countries, Russia, Japan, and the United Arab Emirates are discussing future moon missions. Meanwhile, in 2019, the administration led by President Donald Trump announced that it was directing NASA to work on returning humans to the moon by as early as 2025. The initiative, dubbed the Artemis program, relies on commercial and international partners to support a sustainable crewed exploration program powered by NASA's heavy lift rocket, the Space Launch System, SLS. The first mission of the Artemis program, Artemis 1, successfully laid the foundations for lunar exploration when it completed an uncrewed mission around the moon and back. NASA successfully launched Artemis 1 at 1:47 a.m. Eastern Standard Time, 6:47 GMT, on November 16th, from Launch Complex 39B at NASA's Kennedy Space Center in Florida. After a monumental 1.4 million mile (2.3 million kilometer) flight, it splashed down in the Pacific Ocean off the coast of Baja California at 12:40 p.m. Eastern Standard Time on December 11th. In conclusion, the moon remains a symbol of wonder, mystery, and endless possibilities. Its serene beauty and silent presence in the night sky remind us of the vastness and majesty of the universe. As we continue to explore and study this celestial neighbor, may we be inspired by its timeless allure and strive to unlock the secrets of the moon's enigmatic world. Thank you for joining us on this cosmic journey, and until next time, keep looking up at the moon and dreaming of the stars. Safe travels, fellow space travelers.